Hi, good morning, all. How are you, children? I hope all are good. And I am your new teacher, and I am teaching you all subject mathematics. Yes, let us discuss and revise last year portion in this bridge course video. And in this video, what I am teaching students, it's very, very important in your present year 9th class. And come, let us revise those things. Yes, first of all, I am listing here the last year chapters we have in 8th standard mathematics textbook, part 1 and part 2. Both textbooks exercise here, means chapters here. So first chapter is namely in part 1 or in semester 1. It is a numbers, rational numbers, linear equations in one variable, basic concepts related to quadrilaterals, constructions, data handling, square and square roots, cube and cube roots, comparing quantities, algebraic expression and identities, solid shapes, mensuration, direct and inverse proportions, factorization, and lastly the graphs. So these are all total chapters we have in a last year 8th standard textbook. And once again, the quick revision we have go through on all these chapters. We can say the highlights like that. So we can go through this all exercise. Yes. Ready, children? And the last year, the first exercise or chapter in our mathematics textbook is numbers and rational numbers. So I am writing here numbers, rational numbers, and there are set of numbers, means a set of natural numbers, set of whole numbers, set of integers, and a set of rational numbers. Yes. First I am writing here the set of natural numbers. And what is a natural number, dear students? What are the natural numbers? So natural numbers, we simply called it as, counting numbers are called natural numbers. And it is denoted the set of the letter n, and namely we can say 1, 2, 3, 4, 5, 6, 7, so on. So these are called natural numbers, sir. Yes. Definition wise, this is a natural number is a correct. The counting numbers are called natural numbers is a correct. But what I am asking here, what is the exactly meaning and why we called the numbers is a natural numbers only? Why we not named as another name? Means why natural numbers are called natural numbers? What is the relation between nature and numbers, means natural numbers? And see another one, whole number. And why whole numbers we called as whole numbers only? And why all rational and irrational numbers are real numbers, but every real numbers is not an irrational number? Why? Yes, children, we will discuss many why and how in this video, and watch till end and don't miss the video. See, listen, children, in mathematics, in every question has its answer. I earlier said that. Many questions, and why, how, in this type of questions, in mathematics, it has its own answer. And that's what I'm asking here question. Why we natural numbers called as natural numbers? And what is the interconnection between nature and numbers? Yes or no? Yes. I'm telling you, natural numbers means, yes students, I will ask you one question. Just tell the or count the numbers means, what will you do, students? Now just simply counting or telling the numbers How you counting the numbers? Started with 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. Yes, students. Naturally, we are counting and we are starting with the number 1, 2, 3, 4, 5. Why we not used as a 0? We are not naturally called as 1, 2, 3, 4, 5. I am just asking you, yes, tell me the numbers means you are started what? From 1 only. Why you are not started from 0? Yes. Naturally, we called what here? 1, 2, 3, 4, 5, 6, 7. And naturally, we started for what? 1, 2, 3, 4, 5, 6, 7 and so on. That's what we called as what? Natural number. Naturally, we what? Counting here 1, 2, 3, 4, 5. Like that, these numbers are called what? Natural numbers. Yes. And another thing is coming. Sir, why whole number? What is a whole number? See, whole number, I will just write the whole number here. The whole number is started with 0, 1, 2, 3, 4, 5, 6, 7 and continue has on like that natural number only. But it includes one before 0 and we set of whole numbers we denoted in a W letter, English W letter. And why we this called as a whole number? And this question is also a specific meaning, students, in mathematics. See, in a natural number series, 1, 2, 3, 4, 5, 6, 7, so on. What will come after 9, students? After 9, a natural number, in set of natural number. Yes. After 9, yes, now come after 9, anda. Anda means, students, 0. Now, 0 came now. Now, counting of number is completed. Means, this 1, 2, 3, 4, 5, 6, 7, 8, 9, after 9, I am telling you, after 9, 0 came, anda came, means what? 0 is attached to 1 means the number is completed means after 9, 10 is came. Means what? Now the set, the whole number set is what will become here? Yes, students. Now the numbers are Purna ho gayi, means a complete set of numbers. Purna Sankhya or whole numbers we called. That's why whole numbers are started from what? 0. This set is now completed, means it started 0 means this set is completely filled or completely complete ho gaya. Yes or no? That's what we are called in Purna Sankhya or whole number. Yes, one question arises, dear students, here. That 9 after 10 came, no? So, where did 0 come here? Where did 0 come here? 0 come here means here started from 0 only. The set of numbers is completed means then how number 10 will come here? Yes. Number 1 को we are 0 जोड़ा. That's what 10 here क्या हो गया? Complete हो गया. 10 बन गया. So that's what we called as a what? Whole number. Simply we called as a whole numbers are denoted from 0 to 10 and natural number we are denoted as 1, 2, 3, 4, 5, 6, 7 like that. And another one. Set of integers. It is denoted by Z. And what are the integers? Yes. I can write here the integers, integer numbers 0, the middle one, and the right side are +2, +3, +4 numbers, and left side are -2, -3, -4 numbers to minus infinity to what here? Plus infinity. Means set of integers means it includes natural numbers, means see here it includes right side natural numbers And opposite of natural numbers. Opposite of natural numbers means this side. This is opposite of a natural numbers. We can say what? Minus 1, minus 2, minus 3, minus 4, so on up to minus infinity. And together 0. This is important, students. Together 0. 0 from where it come? It is from whole number, no? 0. So here set of whole numbers and set of opposite natural numbers and natural numbers are called what? Integers. The set of natural numbers and set of opposite of natural numbers and the set of what? Whole number are called what? Integers. And simply integers are denoted from right side in positive numbers and left side negative numbers with included number is 0. Clear, students? Yes. Now the set of rational numbers we denoted as a Q letter. So this is a very important, dear students. What is a rational number means? Yes, the numbers which can be represented as a fraction. So how do you write a fraction number, students? Like that? 2 by 3, 4 by 5, or simply we can say that in the form of what? P by Q. The numbers which can be represented as a fraction, see fraction like that denominator and a numerator. Yes or no, students? Denominator and a numerator. Or in the form of P upon Q, or in the form of what? P upon Q or P by Q, where Q is not equal to 0. This is very important, students. Where Q is not equal to 0 means in a denominator place 0 will not come. What about a numerator, students? 0 will come, it's okay in numerator, but not in a denominator part. I will tell you the examples. See, so 1 by 3 is a fraction, there is no doubt, and 5 by 4 is a fraction, and 0 by 2 is also a fraction, rational number, but 3 by 0 is not a rational number. It is simply we called as a opposite of a rational number, means a irrational number. Yes. Why? That Q is not equal to 0, and in place of Q will 0 will not come. Yes. So this is a condition of a rational number we called, and it terminates after a different decimal expansion, and a non-terminating but a repeating number will come here. So what is a rational number? Namely we called as the numbers which can be represented as a fraction, means a numerator or denominator, or the numbers which can represent in the form of a P by Q form. Yes or no? Okay. Here another concept, linear equations in a one variable. Here I am giving some examples for linear equations in one variable: 3x, 4x plus 2, 3x plus y, x plus y plus z, x square plus 2x plus 3. See, we know what is a variable means. Variable is a English small letter, means x here. In this equation, here also x here. In this equation, there are two variables, means x plus y. In this equation or expression, we have three variables, namely said that x, y, z, and here x square and x. Yes. In a 3x, here only one variable is there. Only what? Here one variable is there. And what about in 4x plus 2? 4x plus 2 also in only one variable is there. And what about 3x plus y? 3x plus y, here there are two variables. Here there are what? Two variables is there. And what about x plus y plus z? Here 3 variables is there. And what about this one? Here x and 2x is there. In this expression, x square plus 2x plus 3, observe here, the highest power is a 2. Yes, the highest power is a 2. So this is not a linear variable. Understood? The highest power is 2 means it is not a linear equation or a linear expression, we can say. But in this example, x plus y plus z, here there are 3 variables are there. Hence, it is not a linear equation in a one variable. It is a linear equation, but it is not a linear equation in what? One variable. Yes or no? Consider this example, 3x plus y. In this expression, we have 2 variables. It is a linear expression, namely, but not a linear equation in what? One variable. We have here what? 2 variables are there. We must and should what? In this concept, only one variable. In one variable only, we can solve the equations. That was solving a linear equations in a one variable. But if you observe in a 4x plus 2, it is a linear expression. And it is also a linear expression in what here? One variable. Because here variable, what here? Only one is there. And we observe in a 3x, it is a linear expression, no doubt. And also a linear expression in a one variable, because here also the variable is only one. That's what the variable one expressions, we called it as what? Linear equations in a one variable. And coming to the next one, how we solving the linear equations in a one variable. I am giving here example, that first example here, y minus 10 is equal to 15, and simply here we have to find the variable y, means we have to find the y value. We have to, what we'll do here, the minus 10 we have to send into RHS part. It is already in the LHS part. We have to send in RHS part, means the minus 10 becomes plus 10, and the total sum 15 plus 10, here y is equal to 25. It is a value of y is equal to 25. And now comes to the next one. I am giving here another example. 6 is equal to z plus 2. And what is a variable here? It is only one variable. Z is a variable. Yes. In to the z, another number is there, plus 2. We have to send it what here? RHS to LHS. Means 6, this plus 2, it will become here minus 2. Why it is become minus 2? Means it is LHS part. It is RHS part. Is equal to, after is RHS part, means a right hand side. See here my hand, right hand side. LHS part means it is equal to, before part means left hand side. This is LHS, this is RHS, left hand side, right hand side. The right hand side number we have to send through the left hand side, means plus becomes minus and minus becomes plus. So here is equal to z as it is. Now 6 minus 2 is 4, and 4 is equal to z, or z is equal to 4. The value of z is here 4. And what about this one? It is look like in a fraction, numerator and denominator value. 2x by 3 is equal to 8. Simply what we have to finding here? The variable x value. Here also variable z value. Here also variable y value. And variable x, we have to take it out. And this 3, divisible this 3, it becomes to the right hand side becomes what here? Into, means multiplication, means 18 into 3, and the x value multiplication value becomes what here? Divided value. Means 2 ones are 2 nines are 9 threes are what here? Sorry, 2 ones are 2 nines are and the 9 threes are what here? 27. So this is what we have to find out the solving a linear equation in a one variable. And here I am giving some examples or homework, dear students. T by 5 is equal to 10 and x minus 15 is equal to 50. You do this homework and make the separate 200-page notebook and a bridge course. Write it as a headline bridge course and bridge course homework and solve it. And the next concept is understanding quadrilaterals. So understanding quadrilateral comes under the geometry part, and it is a very important in the 9th standard mathematics also. And let us revision those things what we learned in last year. So quadrilateral is a polygon. So a polygon or are named according to numbers of sides means vertices. So they have if the polygon having 3 sides, what is the name of the polygon? The name of the polygon is triangle, and this is the figure or shape of the triangle or polygon. So namely what we called the polygon means quadrilateral is a polygon. If the polygon having the 3 sides, and what is the number of polygon, and what is the polygon having the 4 sides, and what is the type of polygon, and what is the polygon having 5 sides, what is the number of name of the polygon. So like that the polygon is nothing but a quadrilateral, or quadrilateral is a polygon. We have to find out polygon means polygon are named according to numbers of sides means vertices. So here number of sides are 3, that is a name of the polygon is triangle. A number of sides is 4, the name of the polygon is quadrilateral. A number of sides are 5 means the name of the polygon is a pentagon, the figure. And the number of sides is a 6, the name of the polygon is hexagon and is a figure, and like so on, that is octagon, nanagon, like that polygon will continue. So now we are study about the quadrilateral. Now discuss about the quadrilateral. Yes. Now we are study about the quadrilateral. I now discuss about the quadrilaterals. Which are the different types of quadrilaterals and the properties? Yes, we study now. There are 4 vertices means P, Q, R, S, and 2 opposite sides are equal. 2 opposite sides are equal. Means PQ is equal to SR and PS is equal to QR. Yes. And angle P is equal to angle R and angle Q is equal to angle S, means two diagonals PR and SQ having angle P is equal to angle R and angle Q is equal to angle S. Opposite angles are equal. So now it is a polygon having 4 vertices means 4 sides are called what here? Quadrilateral. Simply we call it as what is a quadrilateral means. It's a polygon having 4 vertices means 4 sides are called simply quadrilaterals. Yes. And sum of 4 angles of a quadrilateral is a 360 degree. That is very important. And the kinds of quadrilaterals means the types of quadrilaterals we can say trapezium, kite, and a parallelogram. And parallelogram you have the rectangle, square, and a rhombus. And the namely said that the sum of 4 angles of a quadrilateral is 360 degree. Yes. Observe here some homework on understanding quadrilateral chapter. Name the different types of quadrilateral and the sum of an interior angle of quadrilateral is yes. So we have to answer these questions in your bridge course notebook, dear students. Yes. Next one is concept is square and square roots. Yes. I am here written that the square numbers here. How many square numbers are here, children? Here, infinite numbers of square numbers here. Infinite numbers of square numbers is there. Now, what is a square number? Exactly. And what is the speciality in a square number? Yes. We can say the number is started here 1. Yes, 1 is a square number and it is a product of simply what? 1 into 1 becomes 1 and it is a square number. The product of 1 and 1 and it is a product of 1 into 1 is equal to 1. It is a square number. And you observe here 4 and it is a square number. It is a product of what? 2 into 2 is equal to what? 4. And what about a 9? It is a square number and it is the product of what here? 3 into 3 and it is equal to 9. So on up to 16, 25, 36, 49 and continue in infinity wise. So we can define that number which can be expressed as a product of the numbers with itself. Here 1 is multiplied with 1 only and 2 is multiplied with what? 2 only. Then the perfect square. And how you find out a perfect square means the perfect square number in unit digit one of these numbers means here in unit digits in the square number. Unit digits means the ending number. The unit digit means ending number. Here one of these numbers will include 0, 1, 4, 5, 6, 9. We call it as what? A square number. Yes or no? And these numbers 2, 3, 7, 8, these are not a square number because in unit place in this number will occur. We call it as not in the square number. Yes. Now then no, how we have to find out the square number means in divisibility rule, you know, in 8th standard. Yes. So this here I am writing here the square number. 1 square is 1, 2 square is 4 and so on up to 25 square is 625 and square root of 1 is 1 and square root of 36 is a 6. Yes. And how we find out the prime factors? You know, the divisibility test. Prime numbers, what are the prime numbers? Namely, we called it as what are prime numbers? 2, 3, 5, 7, 11, so on. Means the number is divisible by 1 or itself. We called it as what? Prime numbers. Yes. And I am giving here one example. That is a square root of 1444 and how we can find out from a prime factorization method. See, you see in the ending number is 4 and we started the ending number 4 is always divisible by 2 means 2 sevens are 14 and 2 twos are 4 and 2 twos are 4. Next, the number is 2 again, the ending number, and I can take 2 here. Now 2 how much 7 means and 7 is not there in 2 table and we take the nearer number. 2 threes are 6 and 1 left here we can carry means it becomes now 2 to 12 means 2 6 are 12 and 2 ones are 2. Yes. Now 361 is a square number of from which number? 19. Then it is what? Divisible by 19 means 19 how much is 361? 19 19s are 361 and simply we called 19 ones are 19. So it's finally square root of 1444 is equal to, what are numbers is divisible numbers here? 2 into 2 into 19 into 19. Make a group here and take only one time, means here in this group only 2 and here in this group only 19, and 19 to 2 is 38. Therefore, square root of 1444 is what here? The answer 38. So this is how we have to find out the square numbers by the prime factorization method. And simply I am giving here again the homework, and write it in your notebook and solve this homework. Yes. Now the next thing is concept is algebraic expressions and identities. Yes. Students, tell me what are expressions or algebraic expressions. See, not a human expressions or not our expressions here. It is a mathematical expression or algebraic expression. So expression or algebraic expressions are the combinations of what? Constant terms and variables. Combinations of what here? The constant terms and variables. We simply called it as algebraic expression. So I will give you one example here. 2x plus 7. It is algebraic expression. And here 2 is a constant term and x is a variable. You earlier we know that the variable. What is a variable means? Add 7 means it will become here what? Algebraic expression. And it is what here? Binomial term. This term is a binomial term. Yes or no? Now another example, 5y square. So 5y square is also a algebraic expression, but it is what? Monomial term. Yes. Now the question arises, children. What is a monomial, binomial, trinomial and polynomials? Yes, simply we can call it as a monomial has a single term, and binomial has a two term, trinomial has a three term, and polynomial has a three or more terms. The word it says mono means single term, bi means two terms, tri means three terms, and poly means three or more, like that, many we can call it. So monomials means simply monomials are algebraic expressions having what? Only one term. And binomials means binomials are algebraic expressions having only what? Two terms. And trinomials means trinomials are algebraic expression having three terms. And a polynomial means there are more than three terms. Three or more terms with a non-zero coefficients are called what here? Polynomials. I am giving here some examples. Monomial 2x. The x here means it is only monomial, and it is a x plus y means it's a binomial, and x y z means it's a trinomial, and here we can say x y and y it is a polynomial, and here x square y square means it's a monomial, x square plus y square it is a, here you see the notation here, and here there is no notation, means if we put here any notation plus or minus means it will become what here? It will differentiate one term and another term, means first and second term. Now here x square y square is a totally one term. Here there is no notation here plus or minus, but here you see the plus means it will divides the term in 1 and 2, means here you see 1 2 terms is a trinomial, and like that minus 7y 4x square a plus b plus c and a plus b plus c plus d is all what? Polynomials. Yes, another concept here, students, like and unlike terms. What is the meaning of like and unlike terms? Means the terms having a same variable with the same power. We called it as a like terms. And what is a unlike terms means the terms having a same variable but a different power, or the same power having the different variable, are called as what? Unlike terms. I am giving the examples, then you come to know what are like terms and unlike terms. So I am giving here some examples. 7x, 5x, minus 3x, square root of 7y square, and minus 8 by 3 y square, and minus 6y square. Here you observe the terms having only one variable and a same power. Here the power 1, 1, 1, and here it is 2, and here it is 2, and here it is 2. These are all called what? Like terms. And what are the unlike terms? See, I am writing here unlike terms. 7x, 3y, yz, 4z square, 3y square. You observe here the power is 1, power is 1, and power here the power is 1, 1. Yes, and power is 2, and its power is now 2. So unlike term, the variable are different. If variables are same, the power are different. So it is called what here? Unlike terms. And come to know as quick as much as addition and subtraction of like terms. And you already know that like terms only added and unlike terms cannot be added. So I will give the example. 2x plus 5x, and what is the simply adding here? 2 and 5 or 7, and x is only x, means the coefficients means 2 and 5 add. Yes. So now the second thing, x square plus 3x square. Now tell me the answer here. X square plus 3x square, and what is the value of x here? 1. X value here what? 1. And 1 square means what? 1 only. So 1 plus 3x square means what? 1 plus 3x square means what? Here come 4x square. So another example, 7x square minus 4x square. Here we have to simply minus 7 minus 4 is 3, and the power and variables are same, and keep it as x square and x square. And I already told that like terms are added and unlike terms cannot be added. Guess here, children. Here these two terms are like terms or not? Yes, like terms. Here power is 1, and variables is a same variable. Yes or no? Now see, power is 2, and variable are both are same. Here also power is 2, and variable is both are same. That's we have to do what here? The like terms we can only add those things, and unlike terms we will never add. Okay. So another example is there. AB minus BC, BC minus CA, CA minus AB. We simply have to, what is here? Add, and put the add notation. Means plus AB minus BC plus BC minus CA plus CA minus AB. Yes. And the same terms will cancel each other. Means here AB, here AB, means plus AB minus AB, minus BC plus BC, minus CA plus CA, and totally the answer is 0. And now come to the multiplication process. Multiplication process, how we can multiply like terms. See the one example, 2p bracket 3 is equal to, and the second one, 2p square bracket complete 3p raised to 5 is equal to, and the third one, 6p bracket of 0 is equal to. So now
guess what the answer, easier one. 2p into 3 means, and here 3 is a variable, 2 3s are 6, and p keep as it is. 2p square 3p raised to 5 means 2 and 3, 2 3s are 6, and this powers will in multiplication process what here added. In the rule of exponents we can say the power in multiplication process the powers will what added means 5 plus 2 is a 7. We know that a raised to m into a raised to n is equal to what here, a raised to m plus n. There is an exponential rule. And what about 6p into 0? Anything number multiplication by 0 is 0 only. Here also 6p into 0 is 0. Yes. And now take some typical one, means fourth one, 2x plus 5 and it is a 4x minus 3. And it is the multiplication process of binomial terms. See here binomial terms. 2 terms means binomial. Here also 2 terms means binomial. It is a binomial to binomial multiplication process. And how we can multiply? It is simply 2x taken out and the second term 4x minus 3 plus, and 5 take it out and the second term 4x minus 3. And we know how the binomial term multiplication process in 8th standard, and simply we have to multiply this. 2x into 4x means 8x square minus 2x into 3 is a 6x. 5 into 4 is a 20, x means x, and 5 into 3 is a 15, and the sign is minus and keep it as minus. This is the answer it. Yes or no, students? And next one, fifth one, 2y plus 5 and 2y plus 5. Yes, it is a look like in the form of a plus b and a plus b. Means it is what? A plus b whole square form. And what is the a plus b whole square? A square plus b square plus 2ab. Like that. You have to use this identity and solve that equations. Means 2y plus 5 whole square it becomes. It's look like a plus b means a plus b whole square, and 2y plus 5 both are same terms means it is a 2y plus 5 whole square. And simply in this form we have to solve it. Means a here 2y and b here 5. A square means 2y whole square. B square means b here 5 whole square plus 2 into a only is a 2y and b is only 5. And what about a 2y whole square? 2 into 2 is a 4 and y into y is a y square plus 5 square is 25 plus here 2 2s are 4, 4 5s are 20, and it is a 20y. And how we have to multiply these like and unlike terms, and this is the way. And next come to the, and here students we already solved that by the identity. And here the some important identities: a plus b whole square, a minus b whole square, a plus b, a minus b is a square minus b square, and x plus b is x square plus bracket of a plus b into x plus ab. And now these are 4 identities we can use for the multiplication for algebraic expressions. So the lastly we come to this video, and we have the homework for this algebraic expressions, and write it is in your bridge course notebook and solve in your home. And these are all the homework examples. Yes, I hope all of you understood this bridge course video, and study well and stay at home.